Alright, so we are going to look at resolution of forces, and under resolution of forces we consider the triangle method. So we have the question to be given that 120 Newton force acts at 30 degrees to the horizontal and 100 Newton force acts at 90 degrees to the horizontal. We are asked to determine the resultant of the forces using triangle method. To do this, first you have to take the scale. Since we are given the values in Newton and rule is not calibrated using Newton, so we have to take the scale in cm, so that once we are done with scaling it in cm, we can now use it to plot and then convert back to Newton. So that will take us to the scale. So looking at the scale, we have 1 cm equal to 10 Newton. So for the 120 Newton force, we scale it down to this. So 1 cm equal to this, x will be equal to this. When we cross multiply, we are going to have this, and then because we are looking for x, we make x subject of the formula by dividing it by 10 Newton force, and that will give us 12 cm. Similarly, we do the same thing to the 100 Newton force, which will be 1 cm equal to 10 Newton. X is equal to 100 Newton force. That's the force we are considering. And so when we cross multiply at this point, we are going to have 100 Newton cm equal to x times 10 Newton. Because we are looking for the value of x, we divide both sides by 100 Newton, by 10 Newton. And so when we do that, we'll have 10 cm. What this implies is that for the 120 Newton will be represented in a row by 12 cm, and the 100 Newton will be represented in a row by 10 cm. And so when we are done with the scaling, we can now look at the plotting of the graph. So the first thing we do is to plot the vertical line, and we draw the horizontal line. And so when we are done with that, we go back to the question, and then from the question we have that 120 Newton force is inclined at 30 degrees to the horizontal. And so we bring our protractor, we place it here, Once we place it here, we measure, this is 10, 20, 30. This is where the point of 30 degrees is to the horizontal, and then we remove it, fix the point, and draw a straight line to pass through that point. And we call this 30 degrees because it's actually inclined at 30 degrees to the horizontal. And then for the 100 Newton force, we have to do the same thing. First, in order to establish a point, we have a point straight line here, that so that we have a reference point. And then because it is inclined to the horizontal at 90 degrees, so we have this, we place it here. So when we place it here, this is where a 90-degree point is. This is 90 degree, so this is where the point is. So we can now draw it down to meet this horizontal line at 90 degrees for the 100 Newton force. So when we take this down, so that is 90 degrees, so which means this other force is meeting it at 90 degrees. So we have that for the 100 Newton force from the question that it is 90 degrees to the horizontal. So, but we remember that from our scaling, the 100 Newton force is 10 cm. So we now take a row, we look at it. This is, okay, 1, 2, down to 10 cm. That's what we measure, 10 cm. And we take it from this reference point, and then we have a 10 cm to be here. Okay, this is a 10 cm. Yes, so that is where our point is. And I said earlier, when you are taking graphical method of resolution of forces, so you consider the head to tail. So when you draw the first vector line, the second one begins from the head down. So head to tail, you don't come here to draw. And so now that we've gotten this is 100 Newton force, which is equal to 10 cm. So we've gotten that. So since we've gotten that, we now look at drawing our resultant down. So this will now be our resultant. So we take our resultant down. This is our resultant. So this is R, which is equal to our resultant. Note, we have to also measure the value of R So we take the value of R, we take the measurement. From my measurement, let's see, from my measurement here, my value of R is 11.3 cm. So we've gotten the value of R to be 11.3 cm, but then we are not looking for the resultant in cm, we are looking for the resultant in Newton. So we have to go back to our scale and do a conversion from cm to Newton. So from our scale we have that 1 cm equal to 10 Newton. And so our resultant, which is now 11.3, will now be 11.3 cm equal to x. So when we find the value of this x, we'll get the value of our resultant in Newton. So when we cross multiply, we are going to have x times 1 cm will be x cm, which will be equal to 11.3 times 10 Newton will be 11.3 cm times 10 Newton. So 10 Newton. So this can cancel out this. So we now have that x will be equal to 11.3 times 10 Newton will give us 113 Newton. So this is now our resultant, okay? This is now our resultant. So since we represented our resultant with R, we can say equal to R. So this will be, let's put here to be R. So let's put here to be R. So this becomes what? Our resultant. This becomes what? Our resultant in Newton. So basically this is how to find